Boston Dynamics Spot. Spot is the most widely deployed legged robot on Earth, and the only commercial quadruped that walks by treating every step as a controlled fall and catching itself before it hits the ground. The body weighs 72 pounds, the same as a full-grown golden retriever, and carries a payload of up to 30 pounds. It walks at 3.6 miles per hour, near human walking pace, and steps over obstacles a foot tall. The 12 electric motors driving its joints are coordinated by an onboard computer reading torque, joint angle, and depth from a 360-degree stereo camera array. When a foot slips on oil or wet metal, the gate adjusts within a fraction of a second to redistribute load across the remaining 3 legs. If the robot is knocked sideways, it can trigger a self-righting sequence that flips it back onto its feet. Spot was designed to enter industrial sites that are dangerous to humans. It inspects radioactive containment buildings, high-voltage substations, offshore gas platforms, and active tunnels, scanning for gas leaks, thermal failures, and structural fatigue, pulling personnel out of inspection routes that were never safe to begin with. General Electric Walking Truck. The walking truck is the only quadruped at full vehicle scale ever controlled without a computer. Built by Ralph Mosher at General Electric in 1968, the prototype weighed 3,000 pounds, stood 11 feet tall, and ran on a 90-horsepower gasoline engine driving a high-pressure hydraulic pump. The pilot sat strapped inside the cab with both arms and both legs harnessed to mechanical linkages. The arms controlled the front legs of the machine. The legs controlled the rear legs. There was no software, no balance algorithm, and no automatic stabilization. When a foot struck a rock or sank into soft mud, the resistance traveled back up through the hydraulic valves and pushed against the pilot's body, giving the operator a physical sense of the terrain through their own limbs. Top walking speed was 5 miles per hour, and the machine stepped over piles of railroad ties during testing. After roughly 15 minutes inside the cab, pilots emerged drenched in sweat from coordinating 4 legs simultaneously. The walking truck proved hydraulic force reflection could scale, laying the groundwork for the heavy robotic arms and powered exoskeletons built since. The surviving prototype sits in the United States Army Transportation Museum at Fort Eustis, Virginia. Spider crane. The spider crane crawls into a building on rubber tracks, splays 4 hydraulic outrigger legs across a polished marble floor, and at the top end of the category lifts 20,000 pounds without scratching the surface beneath it. Compact models from Maeda, Hoflon, and Furukawa Unique retract their tracks narrow enough to pass through a standard doorway, then expand a stabilizing footprint several yards across to hold a telescoping boom reaching 72 feet into the air. The lift envelope is enforced by an overturn protection system. Load cells in each outrigger foot continuously measure ground pressure, and an onboard computer tracks the position of the center of gravity in real time as the boom rotates. When ground pressure on any one leg drops toward the tipping threshold, the crane locks every movement before the operator can finish the input. Lithium-ion battery-powered versions emit nothing, allowing operation inside warehouses, cathedral interiors, and high-rise lobbies. Contractors routinely lift a spider crane onto the unfinished roof of a skyscraper using a tower crane, then walk it around the structural slabs to install glass facade panels from the inside. Kawasaki Corleo. Corleo is a hydrogen-powered 4-legged vehicle designed to be ridden, the first concept from a major motorcycle manufacturer proposing to replace the wheel entirely on rough terrain. Kawasaki Heavy Industries unveiled the full-scale prototype at the Osaka Kansai Expo in April 2025, with functional prototypes targeted for the Riyadh Expo in 2030 and a commercial release planned for 2035. The propulsion system uses a 9-cubic-inch hydrogen engine acting as a generator, supplying electricity to motors in each of the 4 independently driven legs. Combustion produces water vapor and no carbon emissions. The rear legs use a swing arm mechanism borrowed from Kawasaki's motorcycle division, moving up and down independently to absorb impacts while keeping the rider's seat level. Each leg terminates in a rubber-coated split hoof designed to compress around loose rocks and grip wet grass, replacing the slipping behavior that makes off-road motorcycles tip on steep trails. The rider steers through handlebars combined with body weight shifts read by sensors in the stirrups. The prototype currently on display can stand and shift posture. The galloping footage Kawasaki released alongside the launch is computer-generated. Hyundai Elevate. Elevate is the first vehicle concept ever shown by a major automaker that classifies itself as something other than a car or truck. Hyundai unveiled it at the 2019 Consumer Electronics Show in Las Vegas, designating a new category called the Ultimate Mobility Vehicle. The body sits on 4 robotic limbs, each with 5 degrees of freedom, each ending in an independently powered electric wheel. On highways, the legs fold flat against the chassis, and the wheels drive the vehicle at normal road speeds with a passive suspension system. When the vehicle reaches terrain that defeats a wheeled rescue truck, including collapsed concrete, deep mud, or a flooded debris field, the legs unfold and the wheels lock. The platform then walks in either a mammalian gait with legs tucked beneath the body, or a reptilian gait with legs splayed outward. The configuration is designed to climb a wall 5 feet tall, step over a gap of the same width, and extend to a 15-foot wide track. The cabin remains level throughout. A passenger using a wheelchair could be lifted onto a raised front porch without a ramp, and a stretcher loaded through the side doors carried across earthquake rubble. Only a working-scale model has been built so far. Hyundai has not produced a full-size prototype. Theo Jansen's Strand Beast. The Strand Beast is the largest walking machine on Earth designed without an electric motor or onboard computer. Each leg is a planar linkage of 11 plastic bars and 11 pivots, with the length ratios between the bars discovered by Dutch artist Theo Jansen using a genetic algorithm during the early 1990s. As wind catches the sails mounted on the body, a horizontal crankshaft rotates and drives every leg through one full walking cycle per revolution. The foot traces a flat path during the stance phase, then lifts and resets, mimicking the gait of an animal without a single nerve impulse involved. The largest strand beasts reach 39 feet in length, taller than a single-decker bus, and weigh up to 530 pounds, while smaller versions weigh under 200. The structures are built almost entirely from hollow plastic electrical conduit. The light frame distributes ground pressure across dozens of small footpads, allowing the machine to walk over soft beach sand that would trap a tracked or wheeled vehicle. Passive pneumatic systems built from recycled plastic bottles function as a crude analog nervous system. When wind pressure exceeds a survival threshold, a stored pulse triggers a hammer that drives an anchor peg into the sand, securing the structure against being blown apart in a storm. Jansen designed them with the stated goal of pushing loose sand back inland to slow coastal erosion, though in practice they remain art installations rather than functioning erosion barriers. Timberjack Walking Forest Machine. The PlusJack Walking Forest Machine is the only hexapod logging vehicle ever brought to working prototype. PlusTech, the research subsidiary of Finnish logging giant Timberjack, completed the prototype in 1999, and the design later passed to John Deere following acquisition of the parent company. 6 articulated hydraulic legs supported a fully equipped harvester cab with a felling head capable of cutting and processing standing trees in seconds. The machine moved on a statically stable tripod gate, with 3 feet always firmly planted, and the remaining 3 lifting and advancing in sequence. The central computer adjusted leg pressure continuously, preventing the machine from sinking into soft ground and keeping the cab level over fallen logs, boulders, and uneven terrain. It could move forward, backward, sideways, diagonally, and turn in place. Comparable wheeled forwarders of the same period weighed between 23,000 and 24,700 pounds, and the walking machine sat in the same class. The system worked, but it cost too much and moved too slowly for commercial logging schedules. The PlusJack never entered production. John Deere donated the only existing prototype to the Lusto Finnish Forest Museum. Kaiser S12 Allroad. The Kaiser S12 Allroad is a walking excavator, a vehicle category recognized in international standards as a self-propelled construction machine, using independently articulating limbs to step and climb across terrain conventional excavators cannot reach. The S12 operates at 31,300 pounds. The weight of a loaded school bus, runs a 148 horsepower diesel engine, and produces 25,000 pounds of breakout force. Each of the 4 legs telescopes, swings, and adjusts width and height independently. The 2 front legs typically end in heavy steel claw stabilizers, the 2 rear legs in off-road tires. On sheer mountain cliffs, the machine anchors its front claws into the rock face, then uses the excavator boom itself as a 5th limb, pressing the bucket against the slope and using the hydraulic cylinders to push the entire chassis upward. The wading depth is 8 feet, allowing the machine to work inside, flowing rivers up to the level of the cab. The lifting capacity reaches 21,000 pounds at a 10-foot radius. Walking excavators are used in alpine valleys to stabilize landslide slopes, clear high-altitude rail debris, and build flood barriers inside mountain rivers where conventional construction equipment cannot operate. NASA Athlete Rover. Athlete, the all-terrain hex-limbed extraterrestrial explorer, is the first robotic vehicle ever built that resolves the central trade-off of planetary mobility by refusing to choose between wheels and legs. Developed by NASA's Jet Propulsion Laboratory starting in 2005, the first-generation prototype measured 9 feet wide, stood just over 6 feet tall, weighed 1,870 pounds, and carried a payload capacity of 660 pounds on Earth. Each of the 6 limbs has 6 degrees of freedom and terminates in a wheel with one additional degree of freedom. On flat lunar plains, the legs lock into a rigid suspension, an athlete rolls efficiently like a wheeled rover. The design target is 6 miles per hour during traverse, 100 times faster than the Spirit and Opportunity Mars rovers. When the terrain becomes too steep, too soft, or too obstructed for wheels, the wheels lock and athlete walks. The platform climbs slopes up to 35 degrees on solid surfaces and 25 degrees on soft regolith. Because each limb is fundamentally a manipulator, the same legs that move the rover can be fitted with drills, scoops, or refueling nozzles to excavate ice, assemble habitats, or service landers without separate machinery. Dante 2 Volcanic Explorer. Dante 2 is the only 8-legged robot ever sent into the active crater of a volcano. Built by Carnegie Mellon University's Field Robotics Center in partnership with NASA in 1994, the machine weighed 1,700 pounds and walked on 8 pantographic limbs arranged in 2 nested frames of 4 legs each. The body advanced by locking one frame to the ground, lifting and stepping the other frame forward, then anchoring it and pulling the first frame up to match. A tether cable anchored at the crater rim supported the robot's weight during steep descents, allowing it to rappel down crumbling volcanic walls no wheeled vehicle could survive. Operators worked from a station 80 miles away in Anchorage, with telemetry and laser scan data relayed by satellite. In July 1994, Dante 2 descended into the active crater of Mount Spur in Alaska, collecting fumarole gas samples from vents, producing toxic sulfur compounds at temperatures fatal to human entry. Rubber snowshoes were fitted to the legs because the descent route ran through more than 10 feet of snowpack. The mission ended when the robot tipped onto its side on loose volcanic ash during the climb out. The scientific data was too valuable to abandon, so a helicopter was dispatched to lift the machine out of the steaming crater. The technology mattered because in 1993, the year before the descent, 8 volcano scientists had been killed in 2 separate sampling expeditions.